In this first video for chapter 12-3, determinants and inverses, the object is to find the inverse of a matrix. And this lesson will prepare you to use matrices to solve problems, including how to find the area of a triangle with vertices anywhere in a coordinate plane. But first we need to talk about the multiplicative inverse of a matrix and the multiplicative identity matrix. So let's define the multiplicative identity matrix first. The identity matrix is always denoted by the letter I, and it's always a square matrix. A square matrix is a matrix that has the same number of rows and columns. So it always has a subscript, the identity matrix, and that defines the number of rows and columns for that matrix. The identity matrix, since it's square, has an even number of rows and columns, or the same number of rows and columns. And what tells you that it's the identity matrix is that it has ones across its main diagonal and zeros everywhere else. So this is a 2x2 identity matrix. We can also create a 3x3 identity matrix denoted with the subscript 3. And again, it has ones across its main diagonal and zeros everywhere else. And you can see the ones across the diagonal on both of them, zeros are everywhere else. These identity matrices will help us determine if two matrices are multiplicative inverses. So the definition of a multiplicative inverse is if you multiply two matrices A times B, and that equals B times A, and that equals the identity matrix, then matrix A and B are said to be multiplicative inverse matrices. They are inverses of each other. So the test to see if two matrices are inverses is to multiply them both forwards and backwards. So let's go ahead and test matrix A and B. First we're going to multiply matrix A times matrix B. And we already learned that multiplication isn't commutative, so just because we do this multiplication doesn't mean that this is going to equal it either. So we have to test both cases. So let's go ahead and pull this first column out. We'll lay it on top. -2 and 3/2. And when we multiply, -2 times 1 is -2. 3/2 times 2 is 6/2, which is 3. Then -2 times 3 is -6. 3/2 times 4 is 12/2, which is +6. Now we'll need to bring out our second column and lay that on top. So we'll lay 1 and -1/2 on top and multiply. 1 times 1 is 1. -1/2 times 2 is a -1. 1 times 3 is 3. -1/2 times 4 is a -2. So when we simplify this matrix, we get 1, 0, 0, 1, which so far checks out. So far, B is the inverse of matrix A, but let's make sure that matrix A is the inverse of matrix B. Then we can say they are inverses. So we'll need to bring this very first column out, 1 and 3. -2 and a +3. We get 1 times 3/2 is 3/2. 3 times -1/2 is -3/2. Oops, that's a 3/2. So let's go ahead and pull that second column out and do our multiplication. We'll lay the 2 and the 4 on top. 2 times -2 is a -4. 4 times 1 is a +4. Then 2 times 3/2 is 6/2, which is a +3. 4 times -1/2 is -2. And when we simplify this matrix, we get 1, 0, 0, 1. There we go. They both equal the identity 2x2 matrix. Therefore, A and B are inverses. How do you write the inverse of a matrix? If you want to write the inverse of matrix A, you would write it like this. This -1 is a superscript. is not an exponent, it is a superscript, and it means the inverse of matrix A. If we wanted to write the inverse of matrix B, we would write that with a superscript. This reads the inverse of matrix B. And so on. We can write the inverse of matrix C, and so on and so on. Now I would like you to test matrix C and D and see if matrix C and D are inverses of each other. Remember, you need to multiply them both forwards and backwards, or because matrix multiplication is not commutative, you need to test both. So go ahead and do that.